What if I told you the universe is even more bizarre, more beautiful, and more mysterious than we ever imagined? Forget everything you thought you knew about space. For decades, we've peered into the cosmos with Hubble, a legendary eye in the sky. But now, a new era has dawned. The James Webb Space Telescope, 100 times more powerful, is rewriting the story of the universe. And it's finding things that are leaving scientists absolutely speechless. From galaxies that shouldn't exist to alien worlds with strange weather, Webb is showing us a universe we're only just beginning to understand. So, are you ready to see what it found? Let's dive into the deepest, darkest corners of space and uncover the secrets that were hidden from us until now. Our first stop is a place that defies our understanding of how the universe began. We've always been taught the Big Bang model. The universe started small and hot, and over billions of years, galaxies slowly formed, growing larger and more complex. But Webb looked back in time, almost to the very beginning, and found something impossible. 6 massive galaxies, fully formed, existing just 500 to 700 million years after the Big Bang. This is like finding a fully grown adult in a nursery full of newborns. These galaxies are as massive as our own Milky Way, but they appeared when the universe was only 3% of its current age. According to our current models, there simply wasn't enough time or matter for them to get that big, that fast. Scientists are calling them universe breakers because they challenge the very foundation of cosmology. Are our theories about galaxy formation wrong? Or is there a new, undiscovered force at play, accelerating the growth of galaxies in the early universe? Webb hasn't given us the answer yet, but it's presented us with a mind-bending puzzle that could rewrite the first chapter of cosmic history. Next, let's journey closer to home, to a world outside our solar system, an exoplanet named K2-18b. This isn't just any exoplanet. It's what scientists call a Hycean world, a potential water world with a hydrogen-rich atmosphere. For years, we've wondered if we are alone, and finding water is a huge step in answering that question. Webb pointed its powerful instruments at this planet, located 120 light-years away, and what it found is sending ripples through the scientific community. Not only did it confirm the presence of methane and carbon dioxide, key ingredients for life, but it also detected a possible signature of a molecule called dimethyl sulfide. Now, why is that so exciting? Here on Earth, dimethyl sulfide is almost exclusively produced by life, specifically marine phytoplankton. Finding it on another planet is an absolutely tantalizing clue. Does this mean there's a vast, global ocean teeming with alien microbes on K2-18b? It's too early to say for sure. This detection is still tentative and needs more confirmation. But it's one of the most promising signs of potential biological activity we've ever found on another world. Webb is essentially sniffing the atmospheres of distant planets for signs of life, and it might have just caught its first whiff. But Webb isn't just looking for life. It's also a cosmic storm chaser. Let's travel to a hot Jupiter, a gas giant named WASP-107b. This planet is bizarre. It's almost as big as Jupiter, but has only about 1/10 of its mass, making it one of the least dense planets ever discovered. Scientists call it a puffy or cotton candy planet. You might think a planet this fluffy would have a calm atmosphere, but you'd be wrong. Webb discovered something extraordinary. Clouds made of sand. That's right, silicate sand, just like on our beaches. But on WASP-107b, these sand grains form high-altitude clouds that rain down into the planet's scorching hot interior. Even weirder, Webb detected sulfur dioxide. The energy from the planet's host star is breaking down molecules, triggering chemical reactions that create this compound, giving the planet the distinct smell of burnt matches. So imagine a giant super fluffy world with clouds of quartz sand and an atmosphere that smells like a struck match. This is the kind of alien weather report only the James Webb Telescope can deliver. It shows us that the chemistry and meteorology of other worlds can be far stranger than anything we could have ever predicted. Now, let's turn our gaze from single planets to the birthplaces of stars themselves, stellar nurseries. For years, our view of these cosmic clouds of gas and dust has been obscured. Visible light can't penetrate them, leaving the most crucial moments of star formation hidden. But Webb sees the universe in infrared light, which can pierce through these dusty veils. And the images it has sent back are nothing short of art. Take the iconic Pillars of Creation in the Eagle Nebula. Hubble gave us a majestic view, but Webb's image is breathtakingly different. It peels back the layers of gas and reveals countless newborn stars, glowing like bright red embers that were previously invisible. We can see jets of material being blasted out from these baby stars as they gather mass. For the first time, we're not just looking at the nursery. We're seeing the infants inside in real time. Another stunning example is the cosmic cliffs in the Carina Nebula. This is a vast, glittering landscape of star birth, where a torrent of ultraviolet radiation from massive young stars is carving out a cavern in the nebula wall. Webb's unparalleled clarity allows us to study this process in incredible detail, helping us understand how stars like our own sun were born and how their formation influences the birth of surrounding planets. These images aren't just pretty pictures. They are data-rich windows into our own cosmic origins. But what about the end of a star's life? Webb is giving us an unprecedented look at that too. Let's visit the Southern Ring Nebula, the beautiful expanding shell of gas cast off by a dying star. From a distance, it looks like a serene cosmic bubble. But Webb's instruments revealed a hidden secret at its heart. For the first time, we could clearly see that this nebula wasn't created by one star, but by two. A pair of stars are locked in a close orbital dance. As one star reached the end of its life, it began puffing off its outer layers. Its companion star swooped in, stirring and sculpting the ejected material into the intricate filamentary patterns we see today. Webb's infrared eye was able to cut through the glowing gas and pinpoint the faint companion star that was orchestrating this entire cosmic light show. This discovery changes our understanding of how many, if not most, planetary nebulae are shaped. It suggests that these beautiful celestial structures are often the result of complex, dynamic interactions between binary stars, a cosmic ballet that unfolds over thousands of years. From dying stars, we now turn to a cosmic monster, a supermassive black hole. Specifically, the one at the center of a galaxy called Sears 1019. This black hole is special. Webb discovered it existed just 570 million years after the Big Bang, making it the earliest, most distant black hole ever found. But it's not just its age that's shocking, it's its size. This black hole is about 9 million times the mass of our sun. That's big. Too big. Just like the universe breaker galaxies, this black hole shouldn't be so massive, so early in the universe's history. How did it grow so huge, so fast? Did it start from a much larger seed than we thought possible? Did it somehow merge with other black holes at an incredible rate? Or was it able to consume gas and stars much more efficiently than our theories allow? The existence of this behemoth in the cosmic dawn is a major headache for astrophysicists. It is another piece of evidence from Webb that the early universe was a far more dynamic, chaotic place than our models predicted, capable of building cosmic giants on an impossibly short timescale. The discoveries just keep coming. Webb has analyzed the atmosphere of a hot Saturn and found evidence of chemical reactions powered by starlight. It has captured the most detailed image ever of a star-forming region, revealing hundreds of previously unseen stellar jets and outflows. It's even given us a fresh look at the planets in our own solar system, revealing faint rings around Jupiter and capturing stunning details of Neptune's rings and storms for the first time in decades. Each observation, each data point, adds a new brushstroke to our portrait of the cosmos. So what does all this mean? The James Webb Space Telescope isn't just an upgrade from Hubble. It's a revolutionary new tool that's forcing us to rethink our place in the universe. It's showing us that the cosmos is more complex, more active, and more surprising than we ever knew. The impossible galaxies, the potential signs of life, the sandy clouds, the hidden stars, these aren't just isolated discoveries. They are clues in a grand cosmic detective story. And the investigation has only just begun. The telescope is designed to operate for over a decade, and we are only in its first couple of years. What other universe-breaking, paradigm-shifting secrets is it going to uncover? We are living in a golden age of astronomy, and thanks to the James Webb Space Telescope, the next great discovery could be just one observation away. The story of the universe is being written, and we have a front-row seat. Thank you so much for joining me on this cosmic journey. If you were as amazed by these discoveries as I am, make sure to hit that like button and subscribe for more deep dives into the wonders of space. Let me know in the comments which Webb discovery blew your mind the most. Until next time, keep looking up.